All right, good morning, everybody. How's everyone doing so far? All right, not bad for the morning. So we're excited to kick off the NgRx track with a topic that's really important to us, and that's reactive testing strategies with NgRx. And it's really important because
quality is at the heart of NgRx. Quality is a core value where we work at Synapse. If the software we write fails, then people's lives could be in danger.
So, as a result, we've tried really hard to embed quality into every decision we've made when designing NgRx. And this testing story is a big reason why NgRx requires you to be so explicit.
This explicitness is in how you write actions and how you model state changes and effects in your applications. We'll talk more about this explicitness later today also.
But you'll see, hopefully, during this talk that this explicitness actually makes testing pretty straightforward in comparison to a non-NgRx Angular application. And simplifying testing is really important because developers only write tests when it is easy to do so.
And the reason for this is because if tests are slow to run and they require a lot of setup, developers tend to not want to do that as much.
Yeah, we both work as tech leads at the company where we work at. And we've kind of realized that developers like the idea of tests more than writing tests themselves.
So if testing applications is exhausting, then we want to make that process easier and more pleasant.
So it is our goal to make testing reactive Angular applications with NgRx both pleasant and fast. And to do that, we're going to cover a couple of testing tools that are going to kind of help us get there, and we're going to set those up in an example project. So the first tool that we want to talk about this morning is Jest.
And Jest is a delightful JavaScript test runner that lets you run your tests in parallel, gives you the ability to do snapshot tests, which we'll cover, and also lets you run your tests in an emulated browser environment.
So at a high level, what does Jest give you? Well, it's easy to set up and configure, and that's important because you already have a test tool with Angular CLI. So if we want to bring in a new tool, it's got to be pretty frictionless to get that set up.
And it's being easy to set up configure. There's a package called Jest Preset Angular that integrates with the CLI that makes that even easier.
It's also lightning fast in comparison to Karma. Jest runs your tests in an emulated browser instead of an actual browser. This means it's both easier to debug a test that's running in Jest, and you're not waiting for a browser to spin up on you.
A big advantage is snapshot testing, which can be used to automate the creation of assertions. We'll use snapshot testing to do reducers, selectors, and components during this talk.
And this snapshot testing is something we want to highlight. Like Brandon said, snapshot testing lets you automate the creation of assertions. We found that when we're writing tests for Angular components especially, one of the most painful parts of writing these tests is setting up these really complex assertions.
And since you can automate this, it lets you capture these snapshots to your file system so that you can compare these changes later on.
So let's take a quick look at kind of how this might help you write a test. So here is the kind of expect statement you might write in a reducer function. And I'm having to assert that my state matches a certain shape. And in this test, I have to write out the entire state object by hand. And the truth is, I never write this out by hand. Instead, I make this test fail, copy the output, and then paste this back into my test.
I've done that before too, so.
It's a maddening process. And what two-match snapshot does in Jest is it lets you automate this. Instead of copying and pasting from the terminal when a test fails, it's just going to capture the output one time for you, write it to the disk, and then every time that test runs again, it's going to compare it to that good snapshot. So here, we can replace this two-equal assertion with two-match snapshot. And it's going to be that easy. And we're going to use this all throughout the day today. So what does this look like when it gets written out to the file?
So behind the scenes, Jest, like we said, Jest creates a snapshot file that accompanies your spec. And this file gets checked in the source control. As you can see here, the title of the test that we'll write is captured in the actual file itself to let you be able to point at a particular snapshot.
And now each time this test runs, it's going to verify that the input to my test matches the output that I've checked into source control. There's a couple of downsides to this that we should highlight, and that is really that we can trust this tool to work correctly, but we need to verify the snapshots. It's so easy to generate a snapshot to your file system and say, all right, that's great, I'm not going to open up that snapshot file. And it turns out you didn't actually capture the thing you wanted to in your snapshot test. So we need to be able to trust but verify snapshots.
So now that we've talked about how you can use Jest in your project, let's take a look at how you would do that in an Angular CLI project.
So I'm going to let Brandon get this set up. And the thing I wanted to make you or take away about setting up Jest is that it's pretty painless. Like Brandon said, there's a package called Jest preset Angular. And what that does is it gives you really good defaults for running Jest inside of an Angular CLI project.
Right.
So all you need to do is install that with NPM to your project.
Right, so as you can see here, we have Jest set up already, and Jest preset Angular, as we mentioned, that gives you these tools out of the box. And Jest preset Angular comes with a default configuration that you can also extend. So here we're just using a preset, and we're setting a setup file for a little bit of, if you have to override any additional things during your test, like if you have conditions for material. But that's pretty much all you need to start to get up and running with Jest.
And this configuration lives in your package.json file, and that's about as big as the configuration for Jest really gets.
So now we can see that we have all our tests running here.
It gives you a nice output of which tests have run and what the result is, and you can get an idea of how fast these tests take to run.
So now that we've covered Jest, the next tool we'll talk about is Jasmine Marbles.
So this is a node package that's going to integrate with the RxJS test scheduler, and that's going to allow you to write Jasmine tests that allow you to assert against the behavior of observables. And it gives you a couple of important features.
Jasmine Marbles lets you visually test observables by writing diagrams that describe that behavior.
And these diagrams are really important. They're going to allow us to express time and sequencing really elegantly, and this is essential to test complex effects.
It also extends the core set of Jasmine matchers to let you make assertions against the behavior of these observables.
And so this is going to be kind of the mind-melting part. There's a full talk about this in this session today about Jasmine Marbles, and there's kind of an important question I have. Do we have to write marble tests for every single effect?
Yes.
Okay, that's going to suck.
Actually, you don't.
No, this is not a silver bullet testing tool, and we're going to kind of cover it lightly, but this is for your really complex effects, and we'll show you some examples of that later in the talk. Okay, so what does this library look like, and what is a marble diagram? Here's kind of a simple test that we can write using Jasmine Marbles.
So here we're importing two utility functions from Jasmine Marbles, the code function, which lets you create a code observable, and the test scheduler function.
And so what we're doing is we're describing this code observable using a marble diagram and providing that marble diagram with some context. Then we can subscribe to this observable like any other observable, but it's using virtual time, so we then have to get what's called a test scheduler. We flush it to cause virtual time to kind of run instantaneously. So let's walk through this a little bit more.
So each piece in the string of a marble diagram represents a certain thing. So in this case, if we look at what's inside the code function, we have a marble diagram that waits 30 frames or 30 milliseconds of time. It emits a value hello, waits 20 more frames, emits world, 20 more, and then the observable completes.
Okay, but I think we should probably show them a few more examples of this marble syntax before we get to some tests. So again, with that diagram that Brandon was just showing you, every dash represents 10 milliseconds of time. Each character represents an item that observable is going to emit. And then the bar at the end signifies that this observable is going to complete. So this diagram describes an observable that's going to emit A and B at different points in time, and then will eventually complete at some time in the future.
Taking a look at another example, we're going to wait 6 frames, emit a value from D, another couple of frames, and then we're going to use the pound sign to emit an error as opposed to a completion.
So marble diagrams let you both model observables that complete or error out. It can also let you model some kind of interesting observables that come out of the box. For instance, here's one that just kind of keeps on waiting over a duration of time. It never emits a value, it never completes, it never errors out. If you've ever used observable.never, this would be the equivalent diagram for that.
Marble diagrams also let you group emission of values together. So here we're waiting 3 frames. We're going to emit or group the values for A and B together using parentheses, waiting a couple of more frames, and then completing.
So if you've ever written an effect where your service errored out and you didn't actually want to dispatch an action, maybe because we don't do good error handling, this observable should be very familiar to you. This is the empty observable. So it doesn't emit anything, it doesn't wait any amount of time, it just completes right away. So let's go back to this code sample. What is this actually doing, Brandon?
So actually this marble diagram is using the scheduler, as we mentioned before, using the scheduler to simulate time. And after this sequence happened, we call flush to start that sequence and run the, in this case, we're subscribing to the observable and start that test. And this happens using a scheduler.
And so we kind of need to talk about Rx schedulers. And I apologize, but we're kind of going to go into the weeds of how Rx works with these. But basically, a scheduler is a primitive inside of RxJS that simply schedules tasks to perform at a certain time in your application.
Any observable or operator that deals with this uses a scheduler to wait some amount of time.
So what we can do is we can leverage schedulers in Rx to change the behavior of observables and operators to work in virtual time rather than in real time. So if you've ever used the interval observable in RxJS, it is an observable where you can give it a fixed number of milliseconds, and every time that many milliseconds passes, it emits an item. Behind the scenes, this is using a scheduler. And that scheduler is called the async scheduler. It uses set timeout behind the background to create an observable that emits every 17 milliseconds. What we can do is we can actually tell this interval observable, don't use the async scheduler by default. Instead, use a different scheduler. For instance, if we want this one to run in an animation frame instead of via set timeout, we could replace the async scheduler with the animation frame scheduler.
We'll talk about how this integrates further, but there's an interesting nugget in this slide, and if you find out what that is, come see us after the talk's over.
So Marble testing uses virtual time. We've said it a couple of times. And so if we take that previous code example, we can actually make this interval observable operate in virtual time by using the test scheduler instead of the async scheduler.
So with Jasmine marbles, let's see how we would get that running. And this setup is even less involved than what is with Jest, because since Jasmine marbles is integrated with your test runner, all we have to do is install the package, and we can use the package out of the box when you start to write your tests.
When you install Jasmine marbles, it's going to add a custom matcher to the expectations that are built into Jasmine. And it's going to cause your tests to go ahead and flush that test scheduler after every test is run so that you don't actually really have to interact with that test scheduler too much.
So next, we're going to talk about a library that we have used for a while, but we previously open sourced. And that's the Angular testing library.
So the Angular testing library is the last tool we're going to talk about before we start getting into tests. And it gives you 3 things. It allows you to create component fixtures very quickly. If you've ever had to set up a test using the test bed, it can be kind of verbose to get your test set up correctly to make assertions about components.
It also lets you magically mock out dependencies. And I say magic because there's some magic going underneath. But as with anything else, if you want to take a look at the source code, you can see what it's doing underneath.
It also is going to let us use that snapshot testing tool that we showed earlier against Angular components. So what is it going to do behind the scenes?
So we want to keep our tests lightweight. And if you're familiar with the test bed, if you're just using it out of the box without these helper functions, there's a couple of things you would do when you want to keep your tests lightweight and fast. The first is just disabling animations. So we bring in the no-op animations module for that. The biggest one that helps with keep your components lightweight, especially when you're using snapshots, is using the no error schema. This allows you to keep your component templates to use shallow rendering, which only renders those components that you explicitly register in your test or import with any other modules.
And so we were doing this in every single component because as the developers of NgRx, we kind of love boilerplate. But
Don't you talk about boilerplate.
with that being said, we wanted to create a library that kind of did this all for you and give you the right behavior. So with Angular testing library, instead we give you a function that kind of abstracts this away for you called create component fixture.
And create component fixture, as we said, wraps up these utility functions so that you can use shallow rendering out of the box or disable it if you want to do more of a full-blown integration test.
It also allows you to provide all the same test module metadata that you're used to with the test bed. So you can specify imports, declarations, and providers as your test needs them. And what it returns to you is an instance of a component test fixture.
This component test fixture gives you, like I said, a few helper methods to let you compile your component, let you run change detection, get dependencies from the injector, or even access the underlying component for more advanced querying. Because when you're doing component unit tests, these are going to be small, but if you use this fixture with larger components, then you can use advanced querying to get down to individual elements.
And so just like with Jasmine marbles, setting this one up is extremely easy. All you have to do is install it from NPM and it'll just work. So those three testing tools out of the way, let's get to what we're all kind of here for, and that is testing NgRx. And we're going to use these three tools to write fast, performant tests for an NgRx application.
So let's look at some of our test targets with NgRx. And if you're familiar with this, these are the building blocks that we use that we're going to write these tests for.
So first, we're going to talk a little bit about presentation and smart components. Smart components are the components that are actually store aware. They connect to the store, select data out of them, and dispatch actions. We're also going to show presentation components. They're reusable, and they're more concerned with like layout and styling, and they're mostly built with inputs and outputs or with Reactive Forms library.
We're also going to talk about side effects. And side effects are powerful because they reduce the responsibility of components to only dispatching actions and selecting state.
They're going to be the hardest tests to write, but we're going to leverage that Marble testing library to hopefully make that a little bit easier.
We're also going to test selectors, which let you select and compose pieces of state using functions.
So that being said, Brandon, why don't you show them the application that we're going to actually be writing some tests for today. So if you've used the example app in the NgRx repo, this is going to seem very familiar. It will allow you to log in to a book collection. And once you are authenticated, it is going to show you your book collection. And we always kind of like this example app because it has a lot of things in it that a normal NgRx application is going to have. It's going to have derived state, complex reducers, and effects that communicate with the backend. So let's get testing.
So first, we're going to talk about testing reducers. And a good thing about reducers is that they are pure functions. So out of the box, they are just easy to test.
So what do you mean by this? Well, let's take a look at a reducer function and talk about the things that we're going to actually want to test about it. There are two conditional branches in this function. Every case statement in a switch is going to count as a conditional branch that we're going to want to try and capture with a unit test. We're also going to want to make sure that we are going to be returning state unmodified if we pass in an action type that is unrecognized by this reducer.
There are a couple of interesting qualities about this function. It is completely immutable, and you'll know that is a pattern that we implement with NgRx. You don't have to worry about modifying any of its arguments.
It's a pure function, and you're going to see how this is going to really reduce the scope of the test that we have to write for it.
So let's talk a little bit about functional purity when we're going about writing these unit tests.
Because this is going to come up a lot in an NgRx application. So a function is pure if it always produces the same output from the given input and has no observable side effects. I copied that from Wikipedia. What does that actually mean? What is a side effect?
Side effects is something that a side effect, if it might modify a global variable or a static variable, read a global variable and modify one of its arguments, throws an exception, or produces side effect code.
And so a reducer function tends to not have any of these qualities. Instead, a good reducer function will always produce the same output for a given state and an action. It doesn't rely on dependency injection. It's not going to require global state for it to operate in one way or another. And it doesn't really have any side effects in those. We've isolated those to the side effects using NgRx effects. So let's take a look at some examples to wrap our head around functional purity.
So this first function is pure. It takes in an input, returns a new string with the name prefixed from the input.
Here's an impure function. And this one's impure because it's taking an array and it's modifying that array by pushing an item into it. This is an impure function because it's modifying one of its arguments.
We have another function here, and this looks familiar where you're bootstrapping your app. This one's impure. It reads from the global state, which is window in this case, and calls side effect producing code, which is bootstrapping your app.
Here's another impure function. This one's using fetch to start an HTTP request. Promises are really eager, so this is causing side effect producing code to start up immediately when I call this function. Here's the tricky one. Any guesses if this is a pure or impure function?
Doing these curveballs.
No guesses? Pure. Yeah, it's pure, and it's kind of a tricky one. Observables are lazy. Nothing happens until you subscribe to them. We're not modifying any arguments. We're not causing any network requests to start up immediately. Instead, for any given input, we're always returning the same HTTP observable, and nothing happens until it gets subscribed to.
So by encapsulating this logic in pure functions, we dramatically reduce the scope of these tests that we have to write.
We don't need to mock out any side effect producing code. That means we're not going to have to set up any spies. We're not going to have to work with the test bed to configure dependency injection. And that's really going to save us a lot of time when writing these tests.
All we have to do is supply the function with legal input defined by the type signature, and then we can assert the output in our tests.
All right, let's write some example tests then for testing a reducer function. So as you'll kind of see, Brandon's a much better typist than I am, so I'm going to let him write the tests this morning. And the reducer function that we want to test really has two things that we want to say about it. We want to verify that if we give it an undefined state with an action, it always returns the initial state back out to us. The second thing that we want to verify is that it'll load books on success. So let's take a look at that first test.
So for this first test, the code that I'm showing you here is using the reducer from the books reducer, and we're passing an initial state, and we're passing in a type that the reducer is unaware of. And in this case, we're just using a type as at init.
We have to cast it as any because when we go write these reducer functions, we give them really narrow type signatures. But really, this is an important test because it verifies that our reducer can handle actions that it wasn't actually aware of.
So saving this test, and if we look at our test bed, we can verify that that test ran and that state passed through that reducer and was returned exactly as it was passed in.
So this is kind of a straightforward test because we already have the initial state being exported from this reducer. But if we want to make an assertion about an actual state transition that maybe adds books to the state, it gets a little bit more complicated. So the first thing we want to do is we want to set up some actions that we're going to pass in to this reducer function. And one of the nice things about it being a reducer function is it is a legal input to array.reduce. So what we can do is we can create an array of these two actions, first init and then load. Then we can call .reduce on that array. We can pass in our reducer function along with the initial state, and it's actually going to give us the final output as the reducer transitioned between those actions. Finally, we can make an assertion that this state matches snapshot. And you'll notice that for a second there, it was underlined yellow. That's because we're using a VS Code plugin called Snapshot Tools that allows us to inspect snapshots from our editor.
So now that we've saved this snapshot, I can actually just hover over the 2-match snapshot and see what is in that snapshot file.
We didn't have to write this assertion ourselves. Instead, this was saved to the disk, and we can capture this and commit it to our repository.
And as he mentioned before, we didn't have to copy that entire block, which is nice.
And so this is a much easier way to write tests for reducer functions. It's very straightforward. pass in some state and some number of actions, and then just snapshot the output. It gives you a quick way to test reducer functions.
So now that we've written tests for reducers, let's take a look at testing selector functions.
And one of the nice quality of selector functions is that just like reducers, these are going to be pure functions. That means we can again leverage snapshot testing to verify they work correctly.
We can also use snapshot testing to verify the output of the selector as opposed to writing brittle object comparisons like we mentioned before.
We'll also take a look at how we can write tests for really complex selectors that require a lot of state setup. And to do that, we kind of need to define that there are two types of selectors in an NgRx application. There are getters, which simply retrieve values from the state, and then there are derivers, and these are the complex ones that take the outputs from multiple selectors and derive some new state from it.
So if we look at a couple of examples here, getter functions are straightforward to test, and these are functions that you'll use in your local reducer file that you'll compose later together.
So all we'll have to do for these is we'll have to pass in some legal state to them and then make sure they got the right property out of that state. We can just use a simple reference equality assertion for these tests. We don't even need snapshot testing.
Derivers are, on the other hand, are a little more complex to test. We could set up an entire mock state to pass in this test, but that requires more setup than we want to do.
One of the nice things about the createSelector function in NgRx is it actually lets you just test the piece of this that is doing something interesting, and that is the projection function. So we'll see how we can isolate the projector function from these selectors and test those independently. So let's jump into testing some of these selectors now. So in this same reducer, there are a couple of selectors, and can we take a look at what those selectors look like? Oh, these are actually generated with the NgRx entity helper. And so what do those produce? Well, that produces two getter selectors, get IDs and get entities. These just get values out of the state. It also has one deriver, select all, which is actually going to do something interesting in terms of bringing those two pieces of state together to produce the full list of books. So let's test that one, since that one's going to be the harder one to test. So the first thing we need to do is we need to pass in some legal state into this function. And we can do that by going up here first and copying the state setup from our previous test. We can also pass in the initial state object being given to us from the reducer function to make sure that this test runs correctly.
So here, as I mentioned before, we can run this function and we can assert against the helper function from this selector to get all the books. In the first one, we took a snapshot of what the entire collection would look like, but here we're just asserting it against the length of the array that's produced by the selector.
And because our initial state doesn't have any books in it, this test is going to fail because the length of that will be 0 instead of 2. We can verify that it fails correctly in Jest.
So next, let's take a look at an integration test that this will be a local selector. So let's take a look at it, integration test higher up that would be used by components.
So this is when we've taken that selector and we've kind of composed it with our global state. And these are where the selectors get really complicated because it requires a tremendous amount of setup.
So if you look at this one, it looks similar to the previous local reducer test I just wrote, but this will be an integration test because the local reducer is just operating on that particular piece of state. This will be operating at a higher level to where if you're composing different pieces of state, this is how you would write this function. And before, you can see how the integration is because selectors in NgRx are memoized, and so we can still pass this state in for this test and assert against that. But we can do, as we mentioned before, there's an easier way to do this, and that's using the projector function. So I've done another test here side by side, which is going to show you how to use the projector function to write a test.
So here, every selector actually exposes that projector function as a static property on the selector itself called .projector. And that gives us access to just that inner function that we really want to write tests for.
Now we don't have to pass in, if you want to override just individual properties in that selector function that's going to be returned, that's where the projector function really comes in handy.
This keeps our selector tests a lot smaller and easier to write than if we have to set up the full integration with all the reducers in our application.
So now that we've talked about how you write tests for selectors, let's look at writing tests for side effects.
And these are the complicated ones. Again, I want to remind you that there will be a full talk later today about testing observables. This is just kind of get you an introduction into what this process might look like.
Side effects provide action or take in actions and return relevant actions with relevant data based on the store based on that result. So let's take a look at an effect.
Well, for a common effect that listens for actions, it's going to initiate some side effect, and then it's going to map the result of that side effect to new actions. So the first thing that we're going to want to verify is that for some given input action, it's actually going to break into performing the side effect.
First we want to verify that the set of actions actually initiated this effect. And then we want to assert against the inner observable to make sure that it behaves correctly.
And so we can do that by looking at the inner part of this exhaust map. We want to verify that it's going to interact with the service call correctly when the action is dispatched. So there's really kind of two things that we want to assert about this effect.
So let's look at the strategies when we're writing tests for effects. We want to use Jasmine marbles to verify the behavior of the inputs, and like you said, use a smaller or simpler observable to test the inner observable.
So let's jump into writing some small effects tests. So in this example application, when the application loads up, it has to reach out to the Google Books service to give us all the books that exist in our collection. And so this effect uses a mapping operator to map from the action into an observable that we're going to map into more actions.
I'll just show you a quick snippet of what he just mentioned here and talking about how the request is made and how we're handling mapping and handling errors before we write the test.
So Brandon's already scaffolded out some of this test, and you can see that we're going to go ahead and use parts of the Angular testing library that Brandon and I have written to mock out that Google Books service.
Here, as you see, we're using Jasmine marbles. We're using a few functions. Jasmine marbles, we're using the provide mock actions functions that comes with NgRx effects. And we're using the Angular testing library that provides the magical mock function and an interface that you can use when you're mocking out these services.
So how does this mock function work? Well, first we're going to declare a variable using the mock type. What this is going to do is this is going to take a service, and it's actually going to look at all the functions on this service and give you a type back that has that service mocked out. It's going to replace all those functions with Jasmine spies.
And if you're familiar with doing this manually, this is the equivalent of using the provide object and providing it with a use class or a use value and mocking out each one of those service calls that exist in a given, those methods that exist in a given service.
And so to set up this magical mock, you can see on line 35, we're using provide magical mock, and we're just passing in the class itself. This is going to set up a provider for us that is going to produce that mock for us.
We're also mocking out the action stream that you would normally use in an effect so that we can pass in our own actions during the test.
And provide mock actions is something that's provided directly in NgRx effects' testing library.
So first, let's look at what a test for this effect would look like. Here, we're setting up these actions that I mentioned in the effect where you're passing in the load action, and we want to assert against what the result is for that.
The next part is we're going to have to actually describe how the observables work in this effect. So first, for the actions observable, we don't really need to do anything with a marble diagram. We can just use observable.of and create an observable of just that input action.
Next, we're going to set up the response that we're expecting to return from this observable and using the expected variable that stores what we want to assert against when we get to that part.
For these marble diagrams, whenever we use a character, we can supply a second object to it that gives that character context. So on line 49 and line 50, we're saying whenever you see an A in my marble diagram, this is actually all the books. When you see a B in these marble diagrams, this is the HTTP response or the action that we're outputting. This gives context to these mock observables.
So the last line in this, excuse me, last line in this test is we're just passing in the effect low collection, and we're using the Jasmine Jasmine marbles function to be observable, and we're passing in the diagram that we expect that observable to output.
And so this lets us make assertions about the behavior of the observable using mock observables created with Jasmine marbles. Like a good live demo, we wrote some tests previously that are failing. That's fine, but the effects test that we just wrote is passing.
Okay, so now that we've written an effect, a test for the books page effect, let's write a test that shows you an effect that doesn't dispatch any new actions, such as using the router to navigate.
And these are the kinds of effects where you put in the effect decorator that this effect doesn't actually dispatch anything. Instead, they just kind of do some side effect in isolation and don't return any actions back out to the system.
So this one is a little more involved, right? Because in the auth service or auth effects class, we have a lot more dependence. We have a lot more dependencies here at the bottom. We have actions, we have an auth service, we have the router and the dialog. And I talked about this during the authentication talk yesterday.
And this would be really painful if we have to set up mock objects for every single service that this effect requires. But thankfully, using the Angular testing library, we can set up magical mocks for most of those services.
So we set up those tests like we did before, we mock out the actions, and then we get an instance of those services during the test. So now we can talk about a simpler test of verifying that the router is called after navigation, after the user logs in.
So first we're going to create a mock user, and then we're going to create the action that's going to be the input to this effect. We're going to set up the action stream. Again, we don't need to use Jasmine marbles for this piece because there's nothing interesting about the behavior we want to assert. We can just use observable.of again to wrap that action in an observable.
So lastly, we can assert that the router navigate function was called when the login success action came in, and it was called with the specific URL books. And we can see what we were doing here and how we can assert against that in our test.
So the general strategies for writing effects tests is if you have a complex effect that has a lot of behavior, reach for Jasmine marbles to describe those behaviors using marble diagrams. If you have simpler tests that are really just input actions, behavior, then output actions, don't reach for Jasmine marbles. Use simpler observable constructs to write those tests.
So next, let's talk about unit testing components.
So ideally, we want to keep the component tests just as small, lightweight, and fast as the effects, reducers, and selector tests we've written. This is actually going to mean that we're going to have to change the way we test components. And one of the things that really slows down a component test is actually running the just-in-time compiler on all the modules that you're going to import into your test. So we're going to want to try and reduce as few dependencies as possible in these component tests.
And to do that, we can leverage snapshot tests. So if we look at this small presentation component, from a testing perspective, we only need to assert that for a given book, it renders the same output.
And that might sound kind of familiar. For a given book, this template's always going to produce the same result. We could really say that this is kind of a form of component purity.
So the same rules apply. For a given set of inputs, a component will also always render the same output.
And what are the ways that we can verify that a component always renders consistently? Well, we can make sure it has no side effects. And that means making sure that the component, again, it's not modifying or reading from a global variable. It's not going to change any of its inputs. It is a bad component if it is modifying the inputs that it has passed. It shouldn't throw an error as a result of rendering the component. And lastly, it should not render any other components that are actually going to have side effects within them.
So if we take a look at this, what a component snapshot test would look like, let's say we started out with a menu and items elements here. We would write, if we changed the contents of that component and snapshotted it to include more things like burgers and tacos, then, or pizza, then
we are very food focused on our team at work.
you could look at what that component snapshot would look like. And we can snapshot many other areas besides components, such as API requests and state that we talked about before.
So let's quickly take a look at writing a snapshot test for a component using Jest in the Angular testing library. So we've got a book preview component that we are going to, or rather a book authors component that we're going to write a test for. And this just prints out all the authors for a given book. So the first thing we need to do is we need to create one of these component fixtures. And what's kind of nice about the component fixture is you don't have to do it in a before each block. You can declare the component fixture kind of at the top of your test. Then, in a before each statement, we need to go ahead and give the Angular compiler time to compile all the components and pipes that we've declared in this test.
Also, you can see here that we're passing in a book property into this object, and the book property exists on the book authors component, that we're going to write the snapshot test for. And that way we can override that component before we compile it and provide that initial data.
So we've compiled the fixture, and now we can write a simple test. We can just say, we should make sure that this fixture has actually compiled successfully.
Oh, I love snapshots.
And so again, it's yellow. He's going to run the test. And behind the background, Jest is going to write a snapshot file for us. Now we can take a look at that snapshot file and see what it's rendered so far.
So now we can see that for this one, it shows the contents of the template and who it was written by. So in the next test, this one's going to be a little more involved. When we walk through that, we're generating a mock book just as we did before. We're just modifying the properties of that book to include me and Mike, of course, because this is our talk.
And then we're going to modify the instance of the component. We're going to set this book to the mock book that we've generated. Finally, we're going to tell the fixture to run change detection, and then we get a new snapshot that has captured that author information. And so this makes it much easier to write tests that are built this way. If you've put component purity and baked that into your process for writing components, you can leverage snapshot testing and the Angular testing library to write tests for them really quickly. So the last one we want to show is containers. We won't show any tests for this one, but we just want to kind of give you an overview of the strategies for them.
Now, container tests are really just store-aware components, and we'll see how this is important in a moment.
So all we really need to make sure is that they work correctly with the store. We also need to make sure that they dispatch the right actions when handling an event. So if we take a look at a common container component, we can see that it is going to dispatch some actions, and it's also going to select state out of the store. But select and dispatch is really just a special version of input and output. Component inputs allow parents to control how the component renders, same with selecting state, and component outputs allow parents to listen for events, similar to dispatching. So for this component, the select statement is really just a store connected input. And when it dispatches an action, it's really just a store connected output.
And as we mentioned before, testing containers really isn't that different from unit testing components. For a given input, that component will produce the same output in your tests.
So if you want to see an example of a container test today, just come find Brandon and I. We'll be happy to walk you through that process. So let's go ahead and recap some of the things that we've learned today about testing a reactive application with NgRx.
NgRx is designed to make testing easier, and that's because of quality, the quality that we want to produce.
We also learned how to use some testing tools like Jest, Jasmine Marbles, and Angular testing library to make writing tests really fast and to keep them running fast.
We also showed you a few strategies for writing unit tests for reducers, effects, and components.
So hopefully this will help you be more productive when testing your NgRx applications. Thank you.